Okay, welcome. Now we're going to do the next section out of our astronomy, chapter 1, Earth, Moon, and Sun, from section 2, Earth in Space. So before you get to the notes, first of all, I want to make sure it's clear that you should have all of these words defined in your notebook. Axis, rotation, revolution, orbit, calendar, solstice, and equinox. All of these words should be complete. If they're not, pause the video, go to your glossary, put all of these down so you have at least that done. That's the basics you should have. Okay, once you're all set with that, let's get started on this part. Okay, so axis. Axis is an imaginary line that passes through the planet's center, its north and south pole. And so here you can see I made this dotted line. This is supposed to be a planet, and this is an N for north, S for south, and we can just kind of fix that up a little bit too on this one here, or rewrite it. Okay, and so here our Earth's axis is tilted at 23.5 degrees. So each planet has its own tilt. In this case, ours is tilted at 23.5 degrees, and it's an imaginary line. It's not real, but it's how much we can see how much is tilted. Okay, and I just fold that over, and we'll do one at a time. Rotation. So here what you want to do is draw a circle, put your axis at imaginary line, and I made my tilted again. This is an arrow coming around in that circular motion, and that's the spinning of the planet on its axis. Picture a ballerina or an ice skater and how they go on there with their feet and they make a turn. Okay, so how I'm using the marker right there. And that counts, that's how we count the length of the day. In this case for our Earth, that's 24 hours it takes for Earth to make that spin around that imaginary line. The next word on our list, revolution. It is the movement of an object around another object. In this case, I put this object, the sun, I put S, and this other object is the Earth, and I put E. This dotted line is that movement it's making, that circular movement around the other object, and that creates a path, if you will, and that path we call an orbit. And for our planet Earth, it takes a length of 1 full year. That's how we count a year to that whole path that it takes, that revolution, that movement around. Okay. All right. Your next word that you have is orbit. And we kind of already talked about that on the other slide there, or the sheet of paper. The path an object has as it revolves around another object. So that we just want to make sure it has its own little note by itself. So that, again, right here, this circular the circular path right here, this movement that the sun is in the middle and the Earth is going around, is the orbit. So with all that said, we can use that to help us define calendar, because a calendar, a system of organizing time that defines the beginning, length, and divisions of a year. So the reason why I have 4 here is because we'll talk about seasons, but we can also draw continuing around. You can see Earth at all parts of this circle around this path. Obviously 1 point at a time. And as it's going around, it takes a whole year to go around, and we can count how long it takes to go around, 365.25 days. And we can mark off the calendar and divide that out and mark it up. Okay, so the last 2 words that are part of this section is solstice. And there is, notice here's the sun, this is the Earth. I didn't put E, but I put this other imaginary belt that goes around this way. It is the equator, which is an imaginary line that runs around the Earth as a horizontal. It's one of the lines of latitude. And you notice that there are two drawn here, but there's only one at a time, because one will be one solstice and the other one is a different solstice, and it's a tilting of either the Earth towards the sun or away from the sun. And notice the tilt is going in the same exact direction, because the Earth's tilt, and this is why we have the reason for the seasons, is always tilted at 23.5 degrees towards that or underneath that North Star as it goes around the sun. And because of that tilt, it creates this uneven heating of the Earth. And this tilt towards the sun is summer solstice, and this tilt away from the sun when it makes this orbit around that time in the calendar will be winter solstice. Okay, and it will happen at two different times of the year. Okay, but always keeping that same tilt. Okay, and equinox is obviously, again, we have the sun and then we have the Earth. I didn't label E for Earth, but there's that equator again. This is two different times during the year and just showing them at the same time, where neither hemisphere is tilting towards or away, but the way it's tilted, it does not get affected by an uneven heating. And this one right here, if you look here, here's summer. So as we're coming around, this one would be fall. And here's winter, and this one is going to be spring. Okay? And these two equinoxes will be equal days and equal nights as well. Okay, that's how you get equinox, because this means equal night. Okay, and for the solstice, what happens is summer will have longer days, shorter nights, because of the tilt and because how much sun is going directly. And this, again, I forgot to mention, this is only for the northern hemisphere. Okay, and then this note right here, for winter, this will have shorter days and longer nights. And again, this for the northern hemisphere. Okay. The southern hemisphere, the opposite is true. The seasons would then be switched, because the direct rays for summer will go directly on this side. So their summer's during our winter, and then this right here is their winter, because for the southern hemisphere now it's the angle is tilted away. Okay, so hopefully that helps you when you're adding your notes in, and I enjoy reading what you have. Thank you so much.